Welcome again to Let's Talk Advanced Chemistry, Chemistry 2. Over here on the right, you see we're going to do titrations. Now, we talked about titrations last year, so I'm not going to take a whole lot of time explaining the process. If you need to go back into the Chem 1, we talk about acid-base, is at the end of that section of titration, where it gives a more thorough explanation of the process, shows a picture, shows the process of using the burette, and all that kind of stuff, the indicator, things along those lines. Definition of titration. Process to determine the concentration of a substance based on the reaction with a substance of known concentration. So when it takes a liquid either in the Erlenmeyer flask or the burette that we know the concentration, and then put it into the other, either add that into the other or use the known concentration into that one to find out how much we need to neutralize it. And then from that reaction, being able to identify the concentration of that unknown acid or base based on the process of titration. So real quick, here's one we did last year. Calculate the concentration of 15.00 milliliters of sulfuric acid neutralized with 0.7865 molar aluminum hydroxide from 10.00 milliliters to 24.88 milliliters. We start with the reaction. So ic acids are 8 sulfate, H2SO4 plus aluminum hydroxide. They're both strong. So it's a direct reaction, aluminum sulfate plus water, and we balance it. There we go. Now we always start with a concentration we know the volume of. This is the volume we know the concentration of. We know the aluminum hydroxide is 0.7865 molar. So therefore, we're going to take the two values in the burette and subtract them. So we take 24.88 milliliters minus 10.0 milliliters and subtract them. We get 14.88 milliliters of hydroxide. Going to put that over 1. Convert to liters because molarity is moles per liter, and using that 0.7865 moles over 1 liter. And then for the balance equation, we're doing aluminum hydroxide and sulfuric acid. So it's a 3-to-2 relationship. So therefore, it's 3 moles of sulfuric acid over 2 moles of aluminum hydroxide. When we multiply through, we get 0.0155 milliliters of sulfuric acid. Now we 0.1755 moles. Sorry, molarity, not moles. So therefore, we're going to have to take the 15.00 milliliters sulfuric acid, convert that into liters, put that on the bottom, multiply through 1.170 molar sulfuric acid. That's my answer. Again, if you need more thorough, go back and look at the Chem 1 notes. Now, what we're going to do next is take this for either weak acid or weak base. So here's a problem. Find the concentration of nitrous acid. If 10.00 milliliters of acid is titrated with 0.0225 molar sodium hydroxide, starting at 5.50 milliliters to 7.87 milliliters. Now, the same process until we get to the end. So again, we take our nitrous acid, which is an I, with sodium hydroxide. 2 minus 1, that's a weak acid. Sodium hydroxide is a strong base. Equilibrium, we're going to generate sodium nitrite plus water, balance the reaction already. We're going to do something different here, though. Because the fact that we're dealing with only specific ions we want to look at, we're going to separate into what we call spectator ions, okay? A hydrogen ion plus a nitrate ion generates a sodium ion plus a hydroxide, and equivalent gives me sodium ion plus nitrite plus water. And we're going to eliminate what we call the spectators, okay? The ones that really don't do anything. At the end of that, then, we generate just what's left. H plus hydroxide gives us what is we call a net ionic equation. We used that earlier this year. All right, so let's do the same process again. We're going to start with a volume we know the concentration of. We know sodium hydroxide from 5.50 milliliters, 7.87 milliliters. We have 2.37 milliliters over 1, and that's hydroxide, not sodium hydroxide. And the reason we can do that is because it's a 1-to-1 relationship. Dissociates 100% sodium hydroxide. So whatever the base is, the hydroxide is the same. Okay, convert to liters, convert to moles using the concentration, and then the molar relationship is 1-to-1. So we have 0.0000533 moles of hydrogen ion. We have to convert that into liters, and we have 10.0 milliliters. So convert that to liters. We're going to get 0.0100 liters, which is going to give us 0.00533 molar. All right, now taking our Ka expression, I want to find the acid concentration. So we're going to bring the acid up and bring the Ka down. So the concentration of the acid is going to be hydrogen ion times nitrite ion all over the Ka. Now we know the hydrogen ion, we know that it's 1-to-1, so therefore that's going to be the nitrite ion as well. So that's going to be 0.00533 squared equal, divide by 4.5 times 10 to the minus fourth equal. When we do that, we get a 0.0631 molar concentration for my nitrous acid. Okay, now I'm going to get one more for you to do. I want you to do this on your own. Take your time, work through, pause the video, find the concentration of 10.00 milliliters of acetic acid, that's my weak acid. If it's titrated with 0.05550 molar potassium hydroxide starting at, so my potassium hydroxide is going to be strong, 10.25 milliliters and ending at 12.49 milliliters. There's my Ka. Any questions, number ltswpd@gmail.com. Remember, like, subscribe, share, and comment. I'll try to respond back. Okay, ready? Here's all the work. Answer is 8.54 molar. Okay, hopefully that's not too bad. Take care. God bless.